In today's video, we're talking audio recording and transcription in our legacy project. We'll be using FlutterFlow's inbuilt actions and some pretty cool API integrations to enable users to capture audio and generate text transcripts. We'll also explore how to store the data securely in our database. By the end of this video, you'll have a solid understanding of how to implement audio features in your own FlutterFlow project. Let's get started and watch the stories come to life.
We're going to illustrate the process by way of a mermaid diagram. You may have seen these sort of process diagrams before. They use different arrow types to distinguish between the initial recording process, then the handoff of the audio file to our backend service, the transcription process, and finally the delivery of the transcribed text back to the user. So where we left off in our last video was with our eras all mapped out for our user. And when they clicked on each era, they were sent to the entries page where we would send the eras document. Now, instead of getting the questions when the user navigates to the entries page, what we're going to do is get all of our questions for all of the eras when our family group ID is set up. It's more efficient and we won't run the risk of question duplication. So this is how our app is looking now. A user chooses an era and it loads up all the questions for that era, allowing our user to record. You'll remember from our first video that we set up our recording button, but it didn't do very much. It just showed a snack bar when it was turned to toggle state of true to say that it was recording, and it said it was recording stopped when we toggled off. We're going to keep those snack bars in, but we'll disable them for now. They'll make a good reminder for what a toggle state means further on in our project. Now, when we turn the toggle state to true, we want to start the audio recording. And FlutterFlow gives us a start audio recording action. Then, when we stop our audio recording, we give it a name so that we can refer to it later in our action flow. But there are a couple more steps when it comes to audio, because our stop audio recording action only saves the audio file to the user's device. We need a way to access it and refer to it from our database. So we need to add in the upload media to Firebase node, which will take that locally stored file, upload it to Firebase Storage, and provide us a URL that we can add in to our database and use it to play the file later on for our user. And that sets us up really nicely to create a new entries document in our database and set up as much as we can. Importantly, this will give us a document reference that we can use later on to update our document once we get back things like our transcription. Now, because we've already set up our schema in FlutterFlow, it's simply a matter of going in and setting each value that the document needs. I like to get them all lined up and fill them in one by one, but of course, that's completely up to you. When we get to the start time entry, I've realized that I've not set that up as a value anywhere when the user hits the record button. So I've gone in and set it up as a page state variable that we can set when the user hits record. That way, when it comes to creating our entries document, we've got a record of the time the user started the recording. The end time we do in a similar way, except because we're at the end time, we can use the global property of the current time. There are a couple of extra values here called summary and transcription. We'll get to these later, so for now, we don't need to add them in here. Our audio value will be the uploaded file URL that our upload media to Firebase node creates for us. We'll give the output of our node a name that we can refer to when we're updating our document later on. And now we're ready to send our audio off to our transcription service to get us a text version of our user's entry. Now let's get a little nerdy and talk about transcription models for a second. There's no shortage of them. Back in 2022, Whisper was the first to really gain popular attention, but since then, the AI transcription world has exploded. You only need to go onto replicate.com and have a look at their dedicated transcription section to see the rapidly evolving pace of AI transcription. And then there's Groq, known for its ultra-fast inference model. And it's the one we're going to choose for this project. They have access to OpenAI's Whisper model, but on Groq hardware, which makes it super fast to execute, which is perfect for when you want speech translated quickly. Now, in the Groq dashboard, with Whisper selected, we want to hit the Get Code button, which will give us everything we need to set up our API call in FlutterFlow. First, we'll create a new API call. We'll call it Groq Transcription. Then we're able to get the URL from the Groq database and copy that in. It's a post call. We see that it needs an authorization token and some variables. Let's set up the file variable first, because it can be the most confusing. To send a file over to Groq and most APIs, you'll need to send a multi-part body request. And that's because FlutterFlow won't let you send an uploaded file any other way. Now for our other variables. We know that we need a Groq API key. And we also need to indicate the model that we'll be using. There's also another variable here called response format, which we'll add in as well. Let's give these default values. Now, under our body tab, we'll need to include our file, which we know comes from our file variable we've just set up, as well as our other two body variables. And response format. Let's not forget the R. Now, we put the Groq key in square brackets and add in our Groq key as an app state variable, because we don't want to hard code that in our API call. Make sure that's persisted. And when you put your Groq key in, make sure you toggle on secure persisted fields. Now back in our action flow editor, we can set up our API call across to Groq. We need to give it a couple of variables. The first is our file, and this is our uploaded file in bytes. We also need to send over our Groq API key, which we've stored in our app state variables, and we've secured it as a persisted app state variable. And then because we've put defaults in for model and response type, we can leave those blank. We'll give it a name of Groq Transcription. And assuming all goes well and our transcription is successful, well, we'll want to update our database. So we'll put in an update document node and give it the transcription that's come from Groq. But how do we know what that response from Groq is going to look like? Well, there's a couple of ways we can do this. The easiest is to jump into the documentation and find the endpoint that we're using, and then look for what the response is going to be. Here's our sample response. It's in JSON, which is great because it means we can jump straight into FlutterFlow's new create data type from JSON feature. We just give it that JSON, which means that we can pass the response from our API call as that data type. You don't have to worry about any sort of murky JSON paths. We just know that the response will be in this structure. So then, to updating our database, we simply select JSON body and then to data type, because we know that the body will be that data type that we've defined. And as always, we should tell the user if something goes wrong. So we put a snack bar in here to say that our transcription has failed. Now let's build out the transcription side of things from the front-end perspective. I've made a couple of components using FlutterFlow's AI component generator. And you can see the prompts I've used here on the right. These are to house each entry every family member makes for that question. And then when clicked, you'll be able to hear the entry and read the transcription. So this will be our component that shows the user that there are entries for this particular question that family members have made. Our next video in this series is all about the UI. So we're just going to mock this up quickly for now. All right, now let's create another component that'll house our list of entries for that particular question. It'll be a list view of these entry list components I've created earlier. We'll give this component the entry document and then tie its play button, title, and date to values from that document. All right, let's break down how we structure our Firebase queries in FlutterFlow, as this is a crucial part of how our app retrieves and displays data. At the top of our widget tree is the scaffold. So within the scaffold, we'll define our first Firebase query. We'll target the questions collection in Firestore, and we'll filter it based on two key pieces of data: the user's family group ID to associate questions with their specific group, and the era ID to retrieve questions from the time period that we're within. The result of this query is one document that contains the exact number of questions our family group have requested for each era. Further down, we have our page view widget, which displays each question on a separate page. We're generating the page view children dynamically using the Firestore collection query result. Within each page view, we use a container to hold the interactive elements. Specifically, we've got our microphone button for recording responses, our play button for playing back recorded responses, and our entries button to view previous responses for the question by any family member in the family group. Now, how do we tie those questions through to an entry that a user might be yet to make or have already made? Inside of each page view, we'll run a second query, this time targeting the entries collection. This query filters data based on the question ID, which links the response entry to the question that's displayed within the page view, and the question index, which identifies the position of the current question inside the page view. Then we'll use FlutterFlow's two different types of conditional visibility to show our play and microphone buttons and our entry button. To determine whether to show the microphone or the play button, we'll use the conditional builder widget. Our conditional logic will check the entries collection to see if an audio response exists for the current question, and if it does, we check whether it has an audio file and whether the user ID matches the currently logged in user. That means we have a file that we can play made by the user that's logged in. So we'll display the play button. Otherwise, we'll display the microphone button, allowing the user to record a response. For the entries button, we'll use conditional visibility. It's similar, but potentially easier to use if we're just dealing with the one widget, such as the one button here. Our logic will be, if any entry exists for the question, regardless of the creator, the entries button is visible. If no entries exist for the question, the entries button is hidden. By structuring our queries and UI components this way, we ensure that FlutterFlow dynamically loads and displays Firestore data in an interactive and efficient manner. Then when the user clicks on our entries item, we'll open up a custom dialog, which will be for our view entries list view, and we'll send it all of the entries for that question index. So let's take a look at where we're at with legacy. We've implemented a login and account creation flow. We've used FlutterFlow's inbuilt flows to simplify the process. And in the next session, we'll implement a process whereby you can invite people to your family group that you've just created. We've implemented not one, but two back-end processes. The first, dynamically creating questions for our family group. And then once the user chooses their era and hits record on one of the questions, we've implemented a second backend process. FlutterFlow has us covered with permissions. If it's the first time they're using the microphone, both iOS and Android will ask for permissions. Then they record their entry and it's transcribed by Groq. Once someone in the family group has answered one of the questions, our entries button pops up, which brings up a list of everyone in your family group's entries. You can easily play the entry right then and there, or click further to read the transcription, which brings up a list of everyone in your family group's entries. But next video is all about the UI. We'll be creating some custom code components, thoughtful animations, and a whole lot more to really bring the polish to legacy. And just wait for the fourth and final episode where we bring AI into the picture to start sorting and summarizing our users' entries in ways you never thought possible. I hope you'll join us. Don't forget to like, comment, and subscribe. And we'll see you in Legacy Part 3.